For this video, we are actually going to get into composing and making new functions. So not actually plugging a value in for x, but leaving the variable in there. So if you remember back to our problem where we talked about the person that builds decks, okay, so if we were going to actually make a new function so that this person only had to plug into one function instead of plugging into the cost of the lumber and the total cost of the deck for their customer. So, you know, if we were to write this with functions instead, so if we were going to write L of X, so this is kind of what it would be looking like. So the lumber cost, if you remember, the lumber cost $12 per square foot. Okay, so you're going to do 12 times whatever the area of that deck was, right? So 12 times whatever the area is, A of X being the area. And then if we looked at the total cost of the deck, okay, the total cost of the deck is actually $1,500 plus 140% of the lumber cost. So if we're just kind of taking a look at these as with the functions in there, and so, you know, generally they're going to give you the square root. So this would be our variable, okay, or sorry, the square footage. So, you know, we'll have 12 times whatever that area is. That's going to go in here, okay, so 12 times the area. And so if you just did, you know, you could calculate this out and then you could just do 1.4 times 12. And so your total cost equation, if you wanted to simplify this, would just be 1,500 plus 16.8 times whatever your area is. So if we had just plugged into here, so if somebody calls us up and says we want a deck to be built and it's going to be 200 square feet, you could just plug the 200 in here instead. So 200 times 16.8 gets you directly to that 3,360 number we saw yesterday, which then added together just gets you to the cost of the deck without having to do 12 times the lumber and then 140% of the lumber and then adding the 15. You can just use this equation, 16.8 times the area of the deck plus 1,500. So that's the idea of compositions and creating a new function so that you can do time. It can be a time saver. Now, obviously, if you're only figuring out one bid for a deck, it's not really going to save you that much time. But if you're doing hundreds of these bids, okay, and people are calling and telling you the square footage, and you're having to go 12 times the square footage, and then 1,500 plus 1.4 times that number, all of that takes time, and with doing a lot of bids, it's going to save you a lot of time this way. So, and then as you get more complicated in business functions, definitely making it much simpler and faster can really simplify some calculations. So let's take a look with a couple functions here. So you'll recognize these functions from the other video. And so we're going to do f of g of x. So remember, the f function up there is the red one, and we are going to take and plug the blue function in. So we're going to take g and put it into f. So now I suggested that in that first video, you got to start with, you're going to take the inner function and plug it into the outer function. So I like to write the outer function down first, okay, without the input. So this is the input, like this is changing. We're going to just plug something else in there. So I just leave that blank. X just represents some input, whatever it is. It happens to be X in this case for the f of X. Like if we said f of Y, then it would be Y squared. Or if we said f of triangle, then it would be triangle squared. Okay, so that's just the input. So now what we're going to be doing is taking and putting g of x in there. Okay, so g of x is going to go into that function. Well, what is g of x? Okay, g of x is the square root of x plus 1. And then we're just going to simplify. So I'm just going to rewrite this down. So f of g of x is equal to, so now we've got this squared exponent touching the square root. Okay, so it's around it's the square root of this whole inside squared, so those are going to cancel, and you're just going to get x plus 1 there. Now, when you talk about, if we were going to talk about a domain here, okay, we have to be careful because the numbers are going to have to work for this input. So you're going to have to look at this domain to decide what the domain of the overall function is. Because if it fails the input, it's going to fail the whole function. And so like this domain here, okay, we need x plus 1 to be greater than or equal to 0. So we'll subtract 1 from both sides. So our domain here is x's that are bigger than -1 or equal to -1. So it can't, our inputs, our x values can't fail that, or they fail this whole function. Okay, and so for our domain here, even though this doesn't, x plus 1 is linear, it doesn't have any failure, we did have to plug into g of x first. Okay, so this domain is -1 to infinity. So it's called an inherited domain, okay, because you are doing a composition, you have to plug into the first one first. We're just simplifying it. So we're not allowed to plug in anything less than -1. Okay, so let's take a look at an example where we just plug in some random shape instead of a variable, just to try to help you kind of figure this out, because this input can literally be anything, okay? It can be another expression, it can be a different variable, it can be a number. So let's just take a look at this, okay? So I'm just gonna, we'll get the red function and the blue function here. Okay, so we've got this g of f of heart. Okay, so we're going to be plugging this heart in. So I would again write down this outer function, okay, because you're going to be doing g of f of the heart, right? And so I would write down that outer function just so that you can kind of see what's going on. So the outer function, the g function, is 3 times some input plus 2. Okay, so 3 times some input plus 2. And I might need a little bit more room than this. Okay, now that input is f of heart. Okay, so we're going to have to plug in f of heart into here. So now we need to do that, right? Okay, so let's go ahead and do 3 times, and then we need to get that red function in there, right? So that's this. So it's going to be something squared plus 5 times something minus 2. Okay, that's something. What's the input of the red function? The heart. Okay, so we're going to plug the heart into the red function, into those inputs. And then we're going to simplify, okay? So this is just heart squared plus 5 heart minus 2. And so what are we going to have to do? We're going to have to distribute the 3 into each piece. Okay, so we'll get 3 times the heart squared plus 15 times the heart minus 6 plus 2. Okay, so we just have 3 heart squared plus 15 heart, and then these are like terms. So -6 plus 2 is -4. And so then that would be your final answer for plugging in g of f of heart. So you plug the heart into the red function and then plug that whole thing into the blue function. All right, let's take a look with some x's. So we're going to do 2 things here. We're going to do f of g of x, and we're going to do g of f of x. Okay, so it's important, again, that you recognize what the inside function is and what the outside function is, so that you can make sure that you get this written down correctly for what you're plugging in where. Okay, so we'll do this one over here first. So we're going to plug the blue function into the red. Okay, so g is going to go into red. So this is your outside function. Okay, g is going into this one. So write down that outer f function. So we've got something squared minus 2 times something. Okay, whatever the input is. In this case, it's g of x, right? So everywhere we had an input, we're putting g of x. Okay, so f of g of x. So what's g of x? Okay, so we're going to plug in for that g of x. So what is g of x? It's x minus 3. So then you need to simplify. So we've got this binomial squared. So remember that's really an x minus 3 times an x minus 3. So you're going to need to FOIL this out or put it in the box. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. You get a minus 6x. Negative 3 times negative 3 is plus 9. Okay, so that simplified that first part. Then we need to distribute this negative 2. So we'll get minus 2x plus 6. Okay, then go ahead and simplify. Find any like terms. You've got that negative 6x and the negative 2x. So you have x squared minus 8x, and then you've got the plus 9 and the plus 6 for plus 15. So that is finding f of g of x. So taking g and plugging it into f. So I'm going to erase this so you can pause the screen if you need to write that down. So we have room to do the next one. All right, so then we will do g of f of x. So now this time we're going to be taking f and putting it into g. So for this one, okay, we're going to be plugging the f function into g. So I want to start with the g function. Okay, so we have the input minus 3. And what are we putting into the g function? We're putting f of x in there. Okay, so g of f of x. So plug in for f of x. What is f of x? Okay, f of x is x squared minus 2x. So then we'll just simplify, and that'll get us our final answer. So for this one, there's nothing connected to these parentheses. There's no squared, there's no number out front, so there's nothing to simplify. So we could just get rid of them. And then there's no like terms. So that just is our simplified answer. So x squared minus 2x minus 3 by plugging f into g. All right, then we can actually write functions, okay? And if you're going to take calculus, these things are, this is big for when you take calculus. But so given h of x equals x minus 3 squared plus 4, determine f of x and g of x, okay? So figure out what the f function is and figure out what the g function is so that h of x is equal to f of g of x. Okay, so your f function is your outer function and your g function is the inside. Okay, so this one needs to be inside of something else. So then you kind of take a look and you try to see, do you see an outer, like bigger function, and do you see something that's maybe inside? So what I'm seeing is this squared, and there's parentheses here. So I'm seeing this as an outer function, and this is on the outside too. So I'm seeing that as your outer function, and then this as the inner function. So g of x is x minus 3, and then now when you write this, the red function, okay, that's now just an x. So x squared plus 4, because then you would take this and plug it in here. So inside function, x minus 3, outside function, x squared plus 4, or input squared plus 4. Take a look at another one. So again, same concept here. Here's the big function, h of x, and we want to figure it out so that f is the outside function and g is the inside function. Okay, so you want to be looking for kind of an outside and an inside. So for me, I'm seeing a square root here. Okay, feels like an outside, right? And then what's on the inside of that is this x minus 3. You still have the rest of this. So do you see that this x minus 3 happens again? So remember, you're calling this your inside function. Okay, so this x minus 3 is the inside function. And then everything else is the outside function. And then when you cover up that inside function, okay, that's just an input. So then that would just have an x for the f of x part. So that wherever you see this x, you'll end up inputting that x minus 3. So when we go to replace this, it'll replace here and here. So it'll be square root of x minus 3 plus 1 over x minus 3. So when you it's kind of nice to be able to, draw with the colors and then just cover up that input. And then that input will just be an x, as long as this says x. All right, that is it for this video.